All right, we're in section 8.6 where we're going to be asked to identify the special quadrilaterals. So during the course of this chapter, we've been able to kind of take a look at um, different quadrilaterals, with their specific names and their specific characteristics. So what we are going to be asked to do is identify them, whether it's you know, by a drawing of a particular quadrilateral, or in the notes that we're going to look at is we're going to be given vertices of a quadrilateral. I'm going to be asked to name the most specific name of the quadrilateral. And I believe they're going to ask us to explain. Okay. So, this is where using the other portions of your notes will be really helpful. Um, so first off, if anything is a quadrilateral, we know that it's going to be a four-sided figure. So if it's at the very least a four-sided figure, we can say that it is a quadrilateral. Then it gets split into three different more specific categories where it could be a parallelogram, it could be a trapezoid, or it could be a kite. So the question that you have to ask yourself is, when it comes to the opposite sides, are they parallel? And if they are parallel, we have two sets of parallel lines, which means it falls into the parallelogram category. Uh, if it's trapezoid, we have one set of parallel lines. And if it's a kite, that means we have zero parallel lines. Now, just because we have zero parallel lines doesn't mean that it's automatically a kite. You have to have the other characteristics as well, but this is one of the things that we can kind of visualize and kind of break off into. It's either when we, one of these three um, pieces. If it's zero parallel lines and it doesn't fit the kite, it just goes back to quadrilateral. So if we look at the parallelogram, for instance, we have, okay, so we got a parallelogram, we have two sets of parallel sides. Then what we're going to do is you are going to either look at the angle measures in this case, or you're going to look at the side um, measurements. So if we're looking at it where a parallelogram could be a rectangle, that means we have four right angles. And if we're thinking that it could possibly be a rhombus, that means we have four uh, equal sides. And then if we are still in think that it's a rectangle, we think it's more specific than that. If we think it's a square, we also then think that it could also have four equal sides, which means it has four right angles and four equal sides. So it just has all of those different characteristics. If we believe that the characteristics of a quadrilateral only has one set of parallel lines, we know it's trapezoid. If we believe that it could be an isosceles trapezoid, that means that the two legs in the trapezoid are equal. If we think that it has zero parallel lines, and we think it may be a kite, if it is a kite, we also have to take into account that the consecutive sides will be equal. And, we could also, if depending on what kind of example it is, we have to have equal angles of vertices that are attached to sides that are not equal sides. So, like for instance, we have like a kite shaped here. We have this. These two sides are equal. Those are consecutive. These two sides are equal. Those are consecutive. But the two vertices that touch the non-equal sides, those have to be equal. So, with that being said, we are given um, a graph here. We're given four uh, ordered pairs. They want us to give the most specific name for D, E, F, G. They want us to explain. The explanation is going to be a bunch of the statements that we've just made. Is it two sets of parallel lines? Is it one set of parallel lines? Is it zero set of parallel lines? And then can we say, more specific things from there? So again, they want us to give the most specific name. So yeah, they all are going to be quadrilaterals, but we want to know what the most specific name is with the information given. So looking at this first example, we have D is 1, 2, E is 4, 1, F is 3, negative 2, and G is 0, negative 1. So since they'll all fit on this graph, I'll make them all in one unit. So 1, 2 is right there. That's D. 4, 1. That's E. F is 3, negative 2, and G is 0, negative 1. So, uh, connecting these, I got this, I got this, I got this, and I have that. So, right now, I can't draw any conclusions yet. So, the first thing that we have to do is see if we have one set of lines parallel, two sets of parallel lines, two sets of lines parallel, or zero. So again, since we have a graph, I can just look at the slope. So going from here, I got 1, 2, 3, 1. So this is 3 over 1, which is 3. Over here is 1, 2, 3, negative 1. So this is negative 3. This is negative 1, negative 2, negative 3 over negative 1, which is positive 3. And this is negative 1. I'm sorry, this should be negative 1. So this is negative 1/3. Let me draw that again. My bad. This should be negative 1/3. And then this should also be up 1 minus 3. So that's also negative 1/3. So what we can conclude here is we have two sets of parallel lines. So we know at the very least it is a parallelogram. So I'm just going to put here two sets of parallel lines. And now what we got to do is see, okay, first off, are the lines, or the angles, I'm sorry, 90 degrees. So the way that we can figure that out is, are the two line segments that intersect, are they perpendicular? We know from previous lessons that perpendicular lines, when it comes to respective slope, they are opposite reciprocals of each other. So the opposite reciprocal, we flip the fraction, so I go to 3, flipping the fraction makes it 1/3, change the sign, which makes it negative. So yes, these are all 90-degree angles. So now we can say at the very least, it's a rectangle because we have 4 right angles. And then the final thing we have to do is see if it's going to be a square, which means, do we have 4 equal sides. So this is where we get to use the distance formula. So it looks like I'm going to go with, let's try D and F. So D and F, I go here, the distance formula, I'll just write it here, which is x2 minus x1 squared plus y2 minus y1 squared. So I got 1, 1, 2. I'm sorry, this is E. So I got 1, 1, 2, and 4, 1. 1, 2, and 4, 1. So using the distance formula, distance of this is going to equal, looks like 4 minus 1 squared plus 1 minus 2 squared. So 1 minus 4 minus 1 is 3. 3 squared is 9. So I got the square root of 9 plus 1 minus 2 is negative 1. Negative 1 squared is 1. So I got square root of 10. So this is the square root of 10. All right, now I want to check and see if EF is going to be the square root of 10. If it is, then we can say that we have 4 equal sides. So F is 3, negative 2. So let's look at that one. So this one's going to be 3 minus 4 squared plus negative 2 minus 1 squared. So 3 minus 4, negative 1, negative 1 squared is 1 plus negative 2 minus 1 is negative 3. Negative 3 squared is 9. Yeah, it does give us the square root of 10. The opposite side would also be congruent because it has characteristics of a rectangle. So now we have 4 equal sides, which means that the most specific quadrilateral in this case is a square. Okay. Looking at the second one here, looks like I got 13 here and here, which doesn't meet it. So what I'll do is I'll just make these into 2 units. So going here, so I got negative 2, so negative 2, 10, 2, 4, 6, 8, 10. So that's D. And then I got 1, 13, 2, 4, 6, 8, 10, 12, 13, which is E right here. F, I got 5, so 2, 4, 5, and then 13, which is right there. And then I got G, which is negative 2, 6, 2, 4, 6, which I got G right here, and it looks like I got here and here, here and here. So just by looking at it, looks like D, G, and EF are not parallel, but DE and GF could be. So because I have the scaling for this, I'm just going to use the slope formula. So DE in this case is going to be to find the slope of DE is going to be 13 minus 10 over 1 minus a negative 2. So this gives me plus plus. So this gives me 3. This gives me 3. So that gives me 1. So now I'm going to look at GF in this case. So GF, I have the slope of that is going to be 6 minus 13 over negative 2 minus 5. So this gives me 6 minus 13 is negative 7. And over -2 minus 5, which is also -7, which gives me 1. So I have uh, two sets of parallel lines. So, not two sets, I have one pair of parallel lines. Which makes it, at the very least, it is a trapezoid. But now what we got to do is I want to see if it's going to be an isosceles trapezoid. So now I want to see if the two legs, which is represented by DG and EF, let's see if those two legs are congruent. So I can, well, I can do this. So all I got to do here looks like it's going to be 5 and 1, which is going to be 4. And then I got 2, 4, which is going to be 4 as well. So those two legs are in fact congruent. So I got congruent legs. So the most specific name in this is going to be the isosceles trapezoid. And that is being able to identify special quadrilaterals. Hope this helps. Until next time.